Hello, my incredible pre-calculus class. Welcome to our fourth online math adventure. Today, we're going to review graphing our tangent function. We're going to sketch one cycle of 3 times tan of the quantity pi times x minus pi using our 5 steps. Let's review our 5 steps again. The first step is solve a 3-sided inequality. Remember to get 1x all by itself in the middle. Number 2, find the period. 3, identify the increment. 4, list the 5 critical numbers. And 5, sketch one cycle of the function. We're also going to review our standard form for the equation of our tangent function. Y equals a times the tan of the quantity bx minus c plus d. And in order to find 2 consecutive vertical asymptotes, we're going to use this inequality. This is an inequality that we only use for the tangent function, just the tangent function. And here the formula for period, the number of radians that it takes to complete one cycle is pi divided by the absolute value of b. We're going to start looking at our equation, and we're going to put it into the standard form. So here you see that the a is 3, the b is pi, the c is pi, and there is no d, so that means that it's 0. So our horizontal axis will be y equals 0, which is the x-axis. The first thing we're going to do is step 1. We're going to solve our inequality. And when we solve our inequality, remember now we have to get x, 1x all by itself between these 2 inequality symbols right here. So the first thing we're going to do, we're going to add pi to both sides. Not both sides, all 3 sides. So we're adding negative pi over 2 plus pi, and negative pi plus pi, and pi over 2 plus pi. Remember that we can only add and subtract fractions when we have what? Like denominators. So we have here negative pi over 2 plus 2 pi over 2 will give us simply pi over 2. Negative pi plus a positive pi will give us 0, so we have pi x in the middle. And then pi over 2 plus pi, and remember that pi is 2 pi over 2, gives us 3 pi over 2. We're still not through. Here's pi times x in the middle. We have to get 1x, just a plain old x by itself there in the middle. So we're going to divide all 3 sides by pi. Dividing by pi, remember, is the same thing as multiplying by its reciprocal, which is 1 over pi. So it's going to be 1 over pi times the quantity pi over 2, less than 1 over pi times pi x over 1, less than 1 over pi times 3 pi over 2. Here you see the pi's cancel out, so we're left with 1/2. The pi's cancel out, we're left with 1x, and that's what we want, 1x there. And here the pi's cancel out, and we're left with 3/2. Now, remember that when we solve our inequality and get just the plain old 1x in the middle, then the first number here is the first critical number, and it's also where we're going to have one of our consecutive vertical asymptotes. This is the 5th critical number, and it's going to be where we have our second consecutive vertical asymptote. So this is our step 1, solving our 3-sided inequality to get 1x in the middle. Then we're going to find our period. And remember, our period is pi divided by the absolute value of b. And remember, b was pi, so our period is 1 radian. Our increment is the period divided by 4. So if our period is 1, so our increment is 1 divided by 4. Next, we're going to find our 5 critical numbers. And remember that our first critical number that we got from our inequality is 1/2. Remember that 1/2 is the same thing as 2/4. Now I'm changing it to 2/4 because our increment was in fourths, and we can only add and subtract fractions when we have like denominators. So 2/4 plus my increment, 1/4, gives me 3/4, which is the second critical number. 3/4 plus 1/4, the increment, gives me 4/4, which is 1, our third critical number. 1 is the same thing as 4/4 plus 1/4, gives us 5/4. And then 5/4 plus 1/4 gives us 6/4, which reduces to 3/2. So our 5 critical numbers will be 1/2, 3/4, 1, 5/4, and 3/2. So here we have our 5 critical numbers. So what we're going to do now, when you sketch it, remember to put your 5 critical numbers on your XY axis. And remember the A here is 3, which is greater than 0, which means our tangent function is going to be an increasing function as we move from what, left to right. So what we're going to do now, we're going to put down our 5 critical numbers. So this is what, 1/2, 3/4, 1, 5/4, and 3/2. Next, we're going to sketch our 2 consecutive vertical asymptotes. So, and remember that these vertical asymptotes are really not a part of the graph when you graph it. We're simply doing this since we're doing it by hand again, so that we do not go past these vertical asymptotes. Okay. Now we have our A, which is 3. Now remember, we don't have an amplitude when we have our tangent function. We're going to use that A, that is 3, to get a point that is on the graph. So we go up 3 and what? Down 3. Since our equation is looking like this, at our second critical number, we're going to have 3/4, and you go down here to the A. See, the A is what, a 3? And the middle critical number will always be on the axis, that horizontal axis. Then we have our fourth critical number, and our A is 3, so we go up 3. So see, there we have, what, 3 points. Then we have a little portion that is concave down, and then we're going to have a little portion, is what, concave up. And these are getting closer and closer and closer and closer to the vertical asymptotes, but never crossing them, never touching them. So this is one cycle of our tangent curve. Now, tomorrow, you're going to receive a quiz. This quiz will be on Friday. And you can turn it in early if you like, but you can also observe the timeline that I gave you on your syllabus that you printed off or that you downloaded so you could see it. And that's it for now. And my love is going out to you. Thanks. Bye-bye.